Okay guys, let's start understand in ionic equilibria salts of strong acid and weak base, salts of strong acid and strong base, salts of weak acid, strong base, and salts of weak acid and weak base when put in water or on hydrolysis. Alright, so let's start with salts of strong acid and weak base. I hope you are all very clear about what are strong acids. Strong acids are all those hydrochloric acid, sulfuric acid, nitric acid are all strong acids. What are weak bases? Weak bases, as I mentioned earlier in my earlier videos, that weak bases are those which are hydroxides of transition element, inner transition elements, ammonium hydroxide, and those are all the, so this is also hydroxide of transition element, copper. Alright, okay, so like example, copper hydroxide and sulfuric acid. Sulfuric acid, strong acid, copper hydroxide, weak base. Alright, what example I have chosen here is ammonium chloride, ammonium hydroxide, weak base, and HCl, strong acid. So it becomes weak base, strong acid, salt. Alright, weak base, strong acid, salt. On hydrolysis, what happens? Ammonium hydroxide and hydrochloric acid. Now we know salt, whether weak or strong, it dissociates on hydrolysis. Alright, so similarly here also it has dissociated into these two ions. AQ is aqueous medium. AQ is all aqueous medium. Whereas here it is weak base, doesn't dissociate. So what happens is HCl, strong acid, so dissociates. So what we can do is we can cancel Cl minus over here. What remains is H plus. Alright. Now H plus remains, so the entire solution turns acidic owing to presence of this H plus. Alright, so solution turns acidic and it turns blue litmus red. So this would give pH less than 7 whenever it's salts of strong acids, it gives pH less than 7. Keep that in mind, strong acid. So pH less than 7. Now we take strong acid, strong base, just an example, sodium hydroxide, alkaline metal hydroxides are all strong bases, and strong acid I told. So we are taking strong acid and strong base. Alright, so NaCl, the best example, sodium hydroxide, HCl, salt, strong base, strong acid. On hydrolysis gives NaOH and HCl. We know NaOH dissociates into Na plus and OH minus being strong base. HCl also dissociates into H plus and Cl minus being strong acid. And NaCl, obviously salt, dissociates. So here again what we find is we can cancel this Cl and this Cl and Na plus, what remains is HOH, backward forward, OH minus plus H. So water is undisturbed. Alright, so when you take strong acid, strong base, pH is equal to 7. Alright, so that's what it happens. Now let's go to salt of weak acid and strong base. Alright, weak acids, as I mentioned earlier, weak acids are all fatty acids. It could be methanoic, ethanoic, propanoic, butanoic, or lauric, myristic, palmitic, stearic, oleic, linoleic. Those all are weak acids, fatty acids. Strong base, already talked about strong base over here. So I choose sodium acetate, acetic acid, weak acid, sodium hydroxide, strong base. So salt of strong base, weak acid, sodium acetate in aqueous medium gives you acetic acid, and sodium hydroxide in aqueous medium. Now what happens? Salt, as I told you, salts dissociate no matter whatever be it weak, strong, weak, whatever, salt dissociates. So here it does so. Acetate and Na dissociated into acetate and Na plus. Water, acetic acid, weak acid doesn't dissociate. Sodium hydroxide is strong base, so it dissociates. Now let's see what can we cancel over here. We can cancel this, and what remains is OH minus. Right, acetate, very weak, OH minus, so it's a strong base, so solution turns basic. Alright, and turns red litmus blue. So again here pH is greater than 7. Basic. Alright. So see, when we take strong base, pH is greater than 7. When we take strong, pH is neutral. And when we take strong acid, pH is less than 7. So keep in mind, you just have got to keep in mind that whatever is strong, pH would be favoring that. When you are taking strong acid, pH would be less than 7. When you are taking strong base, whenever I say strong acid, strong base, I mean salt. Alright, salt or strong acid, weak base. So strong acid, pH would be acidic. Salt of strong base, weak acid, pH would be basic. And if it's salt of strong acid, strong base, pH would be neutral. Water would be undisturbed. Alright. Okay, now let's come to the fourth part, that is salts of weak acid and weak base. What happens in this? Now just let's take a general, just I've given an example over here. I've just given an example where ammonium acetate and water, hydrolysis of ammonium acetate, ammonium hydroxide, weak base, acetic acid, weak acid, salt of weak acid, weak base. On hydrolysis gives ammonium hydroxide and acetic acid, both weak. Alright, so I've just taken a general example. BA gives you B plus A minus in aqueous medium. Alright, so it is B. When I say B plus, that means it is ammonium plus and CH3COO minus. Alright, acid, and this is base. Alright, weak base, and this is weak acid. Now here what happens is, it all again depends upon strength. It again depends on relative strength of weak base, that is Kb, or weak acid, that is Ka. Whichever is stronger out of the two, pH would favor that. Now for example, Ka, if it is greater than Kb, that is equilibrium constant for acid, is greater than that of base, then it would be acidic, and if it is vice versa, then it would be basic, and if both are equivalent, it would be neutral. So that is what is all about your hydrolysis of salts, alright, in ionic equilibria. Okay.